Four.
Two atria, but they're going to act together. They're going to act as one. And two ventricles, and they're going to act as one. Because we have two masses of tissue. Here's a mass, here's a mass. So the only four things we're going to need to look at are what? What are the four events that can happen here? What are the two events can happen in the atrium? What? Depolarize, repolarize. What are the two events can happen in the ventricle? Depolarize, repolarize. That's it. Now, abnormal things can happen where they don't do that, etc. But those are the two things that are supposed to happen. Now, that is the impulse moving across the muscle. What do we expect to happen as that impulse moves across the muscle? What do we expect to happen to the muscle? Contract. Exactly. Muscles can only do two things. Do what?
Contract or relax.
Contract and relax. The assumption is that if that impulse moves across that muscle will contract. Is that an absolute given? No. Could you have depolarization of the atria and not have contraction of the atria? Yes. Could you have depolarization of the ventricle and not have contraction of the ventricle? Yes. So contraction is a muscle event. Movement of the impulse is, quote, an electrical event. One is going to cause the other, theoretically, and that's the way it's supposed to happen. So when we talk about the electrical activity of the heart, basically only talking about it. We're talking about atrial depolarization, atrial repolarization. Okay, that's it. So, if they don't work right and show up right on that graph, then there's something wrong. Okay? There's something wrong, and you can figure out quite easily where it is, because you're only looking for what? For four events. Now, to some extent, some of them overlap. Two of them overlap in time, to some extent. Which two would you think might overlap in time? Overlap. These are not overlapping, but now they're slightly overlapping. Which two of these four, what do you think, might overlap?
The atrial and the ventricle. And
Wait a minute, one person at a time. Which events? You got four events there. Which two events? What is the depolarization of the atria going to overlap with?
the repolarization of the ventricle.
No.
Suppose, well, these two are going to overlap to some extent. The repolarization of the atria is going to be happening as the ventricle depolarization begins. These two you would not expect, because they're on the end of the thing. They're the beginning of the whole process. You wouldn't expect those two to overlap, but the two in the middle, quote, middle. Now, can your heart beat so fast that even the overlapping is occurring even more than this? Yes, but you're in big trouble if that happens. Because the next event is probably going to be what? If it's beating that fast. Well, it's going to stop for various physical reasons in the muscle. So, those are the four events that we're looking for. And it is an abnormality in one or more of those events, or the space between them, that is going to tell the doctor what might be wrong with this person, or not wrong with this person. Sometimes the people try to make this much, much more complicated than it is. And it can get complicated as to what actually is causing the problem with their heart. That's not what we're getting at here. We're getting at, are these events happening? Are they happening to the extent that they should happen? Are they happening to the length of time that they should happen? And is there a normal length in between them? So, if I have a graph, and this is a graph of something, and this is time, and this is whatever else this is. Well, let's call it millivolts. Okay. What can we look at? Well, the four events. How extensive is that event? Here's the baseline. Now, what can you tell me about these events? These are the same events happening 3 times. What can you tell me about them? Are they happening?
Yes.
Yes. But what can you tell me? Yeah, but something else is a little more obvious.
The first one, or the second two.
The second two are about the same as far as magnitude, but the first one is about half the other, right? Okay. What else can you tell me? Well, are they about the same length? Since this is time, are they about the same length?
No.
Not really. The last one is just longer than the other. And the last one is a little more misshapen, right? This one is a nice symmetrical curve, right? I agree with that. This one is a little more, not as symmetrical, but it's not as weird as that one. Okay? But they're all three the same event. But they're not happening, there's some difference between them. What else time-wise, what else can I tell? What else can I measure here, time-wise? Well, how fast it's beating, okay, how many per second, okay?
The time between the intervals.
The intervals, the time in between them. Well, you have to go another step to measure how fast they're beating. You have to have how many of these per time. This is only one interval, right? And that interval could be, let's say, something like that. And you see the intervals are not the same. That's normal. Quite often we'll have a person who will miss one heartbeat every 5 or 6 heartbeats, and will look like that. So we have the intervals, the interval of the thing, right? And in this case, they're not even the same length, right? And the interval in between them is not the same. On a nice, normal heart, you would expect the intervals in between to be very, very close to get to the same number. You would expect the height of the curve to be the same, within some variation. You would expect the shape of the curve to be. So when a person is looking at an EKG, that's basically all they're looking at, is the intervals in between the curves, the magnitude of the curve, the length of the curve, shape of the curve, etc. Right? What else is there to look at? It's got to be, if this is an X, Y graph, then any change here has got to be in terms of X and Y. Right? If I see that you can take something that looks fairly complicated and break it down to its simplest thing. It's an XY graph. So any variation, et cetera, or change from one to the other has to be in terms of X and Y. Okay. Any questions on that? You didn't get enough sleep last night? Or you're bored?
No, vaccine.
What?
It's a vaccine.
Oh, you're relaxing, okay. All right, here here is a kind of typical looking, sort of typical. I don't want to use that word too much because, now, all right, let's back up just a little bit here. Here we have an object. Okay? And how would you describe the shape of that object? It's a circle. Okay. And it's a three-dimensional object. All right, it's coming out of the board into the board. And right here in the center of this object, it generates impulses. And these impulses spread equally in all directions and equally fast, or whatever the speed is. Okay? And they get out of here. Now, I want to measure these impulses. So where would be the best place for me to put my electrode, my measuring device? The absolute best place. What? In the middle. But to do that, I have to go through this structure right here. He says put it in the middle. So here's my electrode. I'm going to measure. But to do that, that's kind of disruptive. In fact, it might just destroy whatever this thing is by punching a hole through it. All right? So where's the second best place?
At the end of the circle.
Opposite sides of the circle.
He said the second best place, I assume you mean something like this, right here, right? Is that what you mean?
Yes.
Something like that. Does it make any difference where I put my electrodes?
No.
No. Well, make any difference as far as position on the other side? No. In this case, why? Because this thing is in the middle, and the impulses are generated equally in all directions. So if I put it up here versus there versus somewhere else, I should get the same reading. Right? Okay. All that is hypothetical thing. All right, except the heart looks like this, kind of like that. Right? It doesn't look like a Valentine, right? The heart doesn't look like that. It has this larger part with these kind of ear-like things hanging down the side.